Hey guys, today we are going to construct conic sections based on their definition. So those conic sections include parabola, hyperbola, and ellipse. So we will be graphing those three based on their definitions. Okay, so first we will graph a parabola. We'll construct a parabola. Okay, now a parabola has a point right here called the focus, and it has a line here called the directrix. In a parabola, any point on the parabola will be equidistant from the focus and the directrix. So this point from the focus to a point on the parabola will be exactly the same as the distance from the directrix to that point on the parabola. So here we've got L1 and L3. They are always going to be equal in length. So for this point right here on this parabola, from the focus, we are 3 units out, and from the directrix, we are 3 units up. Okay, we can also make a point that is 2 units from the focus, 1, 2, and that same point is 2 units from the directrix. So right here, we are exactly halfway between the focus and the directrix. 2 units here, 2 units here. Okay, now what if we went 4 units from the directrix? 1, 2, 3, 4. We would also have to be 4 units from the focus. 1, 2, 3, 4. If we went 5 units from the directrix, 1, 2, 3, 4, 5, we would have to be 5 units from the focus. 1, 2, 3, 4, 5. So we'll be right here. Then we can go up 6 and then out 1 more ring, so we're out 6 from the focus. 7 units from the directrix, 7 units from the focus. 8 units from the directrix, 8 units from the focus. 9 from the directrix, 9 from the focus, and 10 from the directrix, then 10 from the focus. Okay, so that is half of the parabola. Now the other half will be over here. If we go 3 units above the directrix, 1, 2, 3, we need to be 3 units from the focus. 1, 2, 3. So we'll be right here. 4 units up, 4 units out from the focus. 4 units from the directrix, 4 from the focus. Sorry, that was 5. 6 units from the directrix, 6 from the focus. 7, 7, 8, 8, 9, 9, 10, 10. Okay, so now as we connect these, we will have our parabola constructed. So we've constructed our parabola where every point on the parabola is exactly the same distance from the focus as it is from the directrix. In a hyperbola, there are 2 foci. So there's one here and one here. Okay, so this one's going to get a little confusing with all these different rings, but we've got all these little dotted rings from focus 2 and all these solid rings out of focus 1. Okay, now we also have these asymptotes right here. Okay, so as we construct our hyperbola, we're going to see that the ends of the hyperbola are approaching these asymptotes. In a hyperbola, these 2 lines, L2 and L1, will always have the same difference. So here, L2 minus L1, in this case, is always going to equal 4. It can equal any number. In this case, it is going to equal 4. Okay, so from focus 2 out to here, I've got this line we're calling L2. And from focus 1, I've got this line we're calling L1. And the definition of this particular hyperbola is that L2 minus L1 is 4. So L2 is 1, 2, 3, 4, 5, 6, 7 units. L1 is 1, 2, 3 units. 7 minus 3 is 4. Now what if I go out to 8 units. So if I make L1 8 units, 8 minus 4 is 4. So I've got to go to the fourth ring, this fourth solid ring. 1, 2, 3, 4. They intersect right here. So this is 8 rings from F2 and 4 rings from F1, and 8 minus 4 is 4. Okay, if I go out to the 9th ring from F2, 9 minus 5 is 4. 10th ring minus 6 makes 4. 11th ring minus 7 makes 4. Okay, so I can see my hyperbola coming together here. Now I need to go this other direction. So this was 7 units from F2. Okay, so now we'll go 6 units from F2, and 6 minus 2 is 4. Okay, so this 6th ring, where it intersects this 2nd ring, that is right here. Okay, how about 5 rings out from F2? 1, 2, 3, 4, 5. 5 minus 1 is 4, so that's going to be right here. And it looks like I'm going to have a vertex right here. And now I can actually just start to mirror it over here. Okay, so this one right here, right here. And then I can just start to go out like this. Okay, so this is one side of my hyperbola. Okay, and we can see that on this side here I'm approaching this asymptote, and up here I'm approaching this asymptote. Now this mirrors over here. Okay, so this vertex mirrors right here, and then from there I can just start to mirror everything over to here. Okay, so there is my hyperbola. Okay, now we will graph an ellipse. So with this ellipse, L1 and L2 will always equal some constant. So for this particular one, L1 plus L2 will equal 8. And again, I have 2 foci. And this segment plus this segment will always equal the same number. In this case, they are going to add up to 8. So here I have 1, 2, 3, 4, 5. 1, 2, 3. 3 plus 5 is 8. So if I go out to the 6th ring from here, 1, 2, 3, 4, 5, 6. 6 plus 2, they intersect right there. 6 plus 2 is 8. If I go out to the 7th ring, 7 plus 1 is right there. That equals 8. Okay, let's go back the other way. If I go out 4, 1, 2, 3, 4, 4 plus 4 makes 8. 1, 2, 3, 4, they intersect right there. And now that I've got this quarter done, including that one right there, I can actually just reflect that up here and reflect over this way as well. Okay, so this one reflects right to here. This reflects here. This reflects here. So I've got half of the ellipse done. Okay. Then I'm going to reflect this here. This will reflect over here. This goes here. Okay. Then I can reflect this one right up here. This one here. And I've got my ellipse. Okay, now some people would just call this an oval. An ellipse is a type of oval, and this should go kind of around that circle. An ellipse is a type of oval. An oval is just any circle that's elongated in any way. An egg shape is an oval. An ellipse is a very specific oval in which the length from one focus to a point on this ellipse is the same, added to the length from the other focus to that same point is always the same sum. In this case, the sum will be 8 no matter what point I pick. We're going to do another ellipse, and in this case, L1 plus L2 is always going to equal 10. Okay, so it's an oval in which L1 and L2 always equal the same sum, which makes that oval an ellipse. Okay, an easy pair of numbers is 5 and 5. So if I go out 5 rings here, 1, 2, 3, 4, 5, and 5 from this one, 1, 2, 3, 4, 5, they intersect right there. So that's a sum of 10. If I go out from here to the 6th ring, 6 plus 4 makes 10. 7th ring plus 3 makes 10. 8th ring plus 2 makes 10. Okay, then I can come this way, the 6th ring plus the 4th ring, 7th ring plus the 3rd ring, the 8th ring plus the 2nd ring. Okay, so now from focus 1 and from focus 2, I always end up with a sum of 10. Okay, and these reflect over to here. Okay, and now I have enough points to graph my ellipse. So on this ellipse, from any point to focus 1 plus that same point to focus 2 will always add up to 10.